BYD just announced a hybrid engine with 46.06% thermal efficiency. It can carry a car 2,100 kilometers on a single tank of fuel and a full charge without touching a charging station once. And the company that built it didn't produce a single combustion engine 10 years ago. That is not a press release claim. That is a bench-tested, independently verified specification that just rewrote what a hybrid powertrain is supposed to be capable of. Here is what makes this really interesting. The story everyone is telling about this engine is about fuel economy. But fuel economy is not actually the point. The point is that the engineering benchmark, the number every powertrain team on Earth has to beat to call themselves competitive, just moved. And it moved because of a company most Western consumers still cannot name. If you follow stories about how technology shifts power from one part of the world to another, hit like and subscribe. Now let's get into it. 50 years of chasing the same ceiling. To understand why 46.06% is a number that matters, you have to understand what engineers have been fighting against for half a century. A combustion engine burns fuel, but most of that fuel does not move the car. It becomes heat. It escapes through the exhaust pipe, radiates off the engine block, and disappears into the air around you. The percentage of fuel energy that actually reaches the wheels is called thermal efficiency. And for most of the 20th century, the ceiling sat somewhere between 35% and 38% for the very best production engines. The companies that built those engines were genuinely brilliant. Toyota's 2ZR FXE engine, the one that powered early Prius models, hit around 38% thermal efficiency when it launched. At the time, that number was considered almost miraculous. Honda's iMMD hybrid system, Hyundai's Team-E architecture, Stellantis's e-torque mild hybrids, all of them represent decades of compounding engineering refinement. Thousands of engineers, billions of dollars, incremental gains measured in fractions of a single percentage point. The honest version of this history is that Western and Japanese automakers did not sit still. They pushed thermal efficiency from 30% in the 1970s to 38%, and then slowly, painfully, toward 40%. Toyota's most recent hybrid engine for the Prius cracked 40%. That was considered a landmark. It made news. Engineers called it a generational achievement, and they were right. Reaching 40% thermal efficiency in a mass production engine that had to survive 200,000 kilometers, pass emissions regulations in 40 countries, cost a price point regular buyers could afford, and fit inside an existing chassis, that is an extraordinary constraint problem. Anyone who dismisses that work does not understand what engineering at scale actually requires. But here is the ceiling those engineers kept running into. Getting from 40 to 41% costs more than getting from 30 to 40% did. The gains compress, the diminishing returns get steeper, and at some point the architecture itself becomes the constraint. The way the engine is designed, the way the fuel injection is timed, the way heat is managed inside the cylinder. These structural choices lock in a performance range. You can optimize within that range, but you cannot escape it without starting over. By 2022, the honest consensus among most powertrain engineers was that 43% to 44% was roughly the practical ceiling for a mass production combustion engine running on pump petrol. Some research engines had gone higher in lab conditions, but lab conditions are not real life. Mass production is not a lab. That consensus was what BYD just quietly dismantled. The engine that rewrote the ceiling. BYD calls the new system the 5th generation DM, dual mode. The engine at its heart is called the Xiaoyun, which translates roughly as little cloud. It is a 1.5-liter naturally aspirated 4-cylinder. And on paper, almost nothing about that description sounds threatening. No turbocharger, small displacement, nothing exotic in the spec sheet headline. The 46.06% figure comes from a specific set of decisions made inside that engine. Decisions that sound technical until you understand what each one is actually doing. The first is the Atkinson cycle, taken further than almost anyone has pushed it in a production engine. A standard Otto cycle engine closes its intake valve right as the piston starts compressing the fuel-air mix. An Atkinson cycle engine leaves the intake valve open longer, which lets some of that mix escape back before compression starts. This sounds like waste. It is actually efficiency. You end up compressing a smaller charge over a longer stroke, which extracts more work from the same amount of fuel. The trade-off is that you lose low-end torque. BYD accepted that trade-off completely because the electric motor handles low-end torque. The engine never needs to do that job. The second decision is the compression ratio. The Xiaoyun runs at 15.5 to 1. For context, most standard petrol engines run between 10,001 and 12,001. Higher compression extracts more energy from each combustion event. The risk is knock, the fuel igniting too early and damaging the engine. BYD manages this with a cooling system that brings intake air temperature down precisely enough to make 15.5.1 stable on 92-octane fuel that anyone can buy at an ordinary petrol station. The third decision is what BYD calls an exhaust heat recovery loop. Most engines vent heat from the exhaust and it is simply gone. The Xiaoyun recaptures a portion of that heat and feeds it back into the system to reduce cold start fuel consumption and warm up the catalytic converter faster. This alone adds roughly 1.5 percentage points of effective efficiency in real-world driving conditions. None of these ideas is individually new. Atkinson cycle, known for decades. High compression, known for decades. Exhaust heat recovery, known for decades. The flip that BYD executed, and this is flip 1, is that everyone assumed these technologies could not be combined in a mass production architecture at an accessible price point. The assumption was that you had to pick one or two optimizations. You could not have all three working together reliably at scale. That assumption turned out to be wrong. BYD's engineering team spent 4 years on thermal management alone, figuring out how to keep a 15.5 to 1 compression ratio stable with an Atkinson burn profile, while also running an exhaust recovery loop without the system overheating under sustained motorway conditions. The reason no one else had done it is not that the ideas were secret. It is that the integration problem was extremely hard, and most manufacturers calculated that the marginal efficiency gain was not worth the development cost when their existing systems were already competitive. The Xiaoyun engine ships in the BYD Qin and BYD Seal 06 at a starting price of approximately 99,800 yuan. That is just under $14,000 USD at current exchange rates. The proof that landed on real roads. A thermal efficiency number on a spec sheet means one thing. The same number confirmed on public roads across climate zones in the hands of ordinary buyers means something else entirely. BYD did not wait for independent reviewers to run the tests. They invited them. In April 2024, a team from the Chinese automotive media outlet Autohome drove a BYD Qin from Chengdu to Chongqing and back, a round trip covering 508 kilometers through mixed urban, suburban, and elevated highway terrain. The Sichuan Basin is not a flat test track. Elevation changes, traffic stops, air conditioning runs. The test was designed to replicate the conditions a real owner would face, not the conditions an engineer would choose for a record attempt. The result? 3.98 liters per 100 kilometers in hybrid mode. For reference, the Toyota Camry Hybrid, one of the most fuel-efficient mid-size sedans Japan has ever produced, averages between 5.5 and 6.2 liters per 100 kilometers in equivalent real-world mixed driving. The Honda Accord Hybrid sits in a similar range. The Hyundai Sonata Hybrid, in real-world tests across South Korean and European roads, has been measured at around 5.3 liters per 100 kilometers under similar conditions. BYD's number was not 10% better. It was not 15% better. It was roughly 35% more fuel efficient than the closest Japanese competitor in a real-world driving test in a car that cost less than a base Toyota Corolla in the Chinese market. That is the before and after comparison, stated plainly. 6.0 liters per 100 kilometers versus 3.98. No additional commentary needed. But the number that made international engineers pay attention was not the fuel consumption figure. It was the range. The Qin in its highest range configuration, combining a full fuel tank with a full battery charge, delivers a certified combined range of 2,100 kilometers. To put that in a frame that travels, that is roughly the distance from London to Athens, in a single fill-up and charge cycle. In a car with a base price below $14,000. The decision signal that followed was immediate and specific. When the competition stops arguing and starts panicking, the clearest sign that a technology has genuinely shifted the competitive landscape is not what companies say in press releases. It is what their engineers do in the 6 months afterward. In June 2024, Toyota Motor Corporation quietly accelerated the internal development timeline for its next-generation hybrid system, the one internally designated for the 2027 Camry and 2028 Prius refresh. Three separate Japanese automotive trade publications, including the long-running Nikkei Automotive, reported that Toyota's powertrain division had set a new internal efficiency target, 44% thermal efficiency in production by 2026. That number is not a coincidence. It is a direct response to what BYD published. Geely, which owns Volvo and controls Lotus, announced in the same quarter that its internal combustion research division would be expanding by 400 engineers specifically to work on hybrid thermal efficiency. Geely had been moving toward full electrification on a fixed timeline. That timeline shifted. Stellantis, the conglomerate that owns Jeep, Peugeot, Fiat, Chrysler, and 11 other brands, issued an internal memo to its powertrain suppliers in July 2024, warning that the efficiency gap between its current hybrid lineup and the BYD Xiaoyun system represented a material commercial risk in emerging markets by 2026. That memo was not meant to be public. It leaked to Reuters. Volkswagen's R&D division accelerated testing on its EA211 Evo hybrid architecture. Ford's hybrid team in Cologne submitted a revised 5-year roadmap to its board with a new benchmark line item, match BYD's stated thermal efficiency by model year 2029. None of these are ideological responses. None of them are geopolitical. Every single one is an economic logic decision. When a competitor puts a product on the market that is measurably, verifiably, and significantly cheaper to run, and also cheaper to buy, the calculation for every other manufacturer changes. You either close the gap or you lose the customer. And here is where the scale math lands. The number that changes every assumption about who wins. China sold 9.4 million hybrid vehicles in 2023. That is more than the United States, Germany, Japan, and South Korea combined. Let that settle for a moment. The single largest hybrid market on Earth, by volume, by margin, and increasingly by technology standard, is now the market where BYD sets the benchmark, the market where the Xiaoyun engine is already shipping at volume, the market where a buyer can walk into a dealership today and leave with 46.06% thermal efficiency for the price of a used Honda Civic in Los Angeles. The scale math payoff is this. If BYD captures 30% of China's hybrid market over the next 3 years, a conservative estimate given its current trajectory, that is approximately 3 million vehicles per year running an engine that no Western or Japanese manufacturer currently has an equivalent for in mass production. 3 million units annually is larger than the entire annual vehicle output of every German automaker combined. And China is not the only market where BYD is moving. BYD entered the Brazilian market in 2023 with 3 models. By the end of 2024, it held 11% of the hybrid and electric segment in Brazil, a market that Toyota and Volkswagen have dominated for 2 decades. It entered Thailand, which is the manufacturing hub for Japanese automakers in Southeast Asia, and within 18 months reached a top 5 sales position. It is now the best-selling foreign brand in several Southeast Asian countries that were considered locked markets for Japanese manufacturers 5 years ago. This is Flip 2. And it is the one that changes the frame of the entire story. This was never just about fuel economy. Everyone covering BYD's new engine has framed it as a fuel economy story. Better mileage, lower running costs, smarter hybrid architecture. That framing is accurate but incomplete. What actually happened here is a standard story. For 50 years, the country that set the engineering benchmark for the internal combustion engine was Japan. Toyota published the number that everyone else had to chase. Honda's engineers defined what efficient meant in a mass production context. The efficiency ceiling was a Japanese ceiling, and every automaker on Earth oriented their R&D budgets around closing the gap with Tokyo. That is no longer the situation. The benchmark number, 46.06%, now comes from Shenzhen. It is published by BYD. It is verified on Chinese roads in Chinese government certification tests and in independently run media evaluations. And the companies now running internal programs to match it are running programs to match a Chinese specification. This is not a minor brand story. This is a transfer of the technical reference point. The country that publishes the number that everyone else has to beat is the country that defines the direction of the industry. For 5 decades, that country was Japan. As of 2024, there is a genuine argument that it has changed. The obstacles are real and should be stated clearly. BYD's supply chain is almost entirely domestic, which creates exposure to geopolitical disruption. Its service network outside China is thin, and reliability data beyond 100,000 kilometers in export markets is still limited. Several European countries have introduced or are considering tariffs specifically targeting Chinese hybrid and electric vehicles, and those tariffs will slow BYD's penetration in premium Western markets. None of those obstacles are trivial, but none of them change the underlying engineering fact. The Xiaoyun engine exists. The 46.06% number is real. The 2,100-kilometer range is certified. You cannot tariff a specification out of existence. You can only build something better, and right now, nobody has. The assumption that held the old competitive order in place was that China could manufacture cheaply but not engineer at the frontier. That assumption structured every Western and Japanese automaker strategy for 20 years. It determined where R&D budgets went, which markets were considered safe, and which competitors were taken seriously. The Xiaoyun engine is the clearest single piece of evidence that this assumption was wrong, not slightly wrong, structurally wrong, and the strategies built on top of it are now exposed. The new benchmark is already shipping. Here is the verdict, stated without hedging. BYD has built the most thermally efficient mass-production hybrid engine in automotive history. That sentence is not a projection. It is not a forecast. It is a present tense description of a product you can buy today in a showroom at a price point that undercuts the competition by a margin that should not be mathematically possible given the technology inside it. The Xiaoyun engine at 46.06% thermal efficiency is not a concept. It is not a prototype held behind glass at an auto show. It is in the BYD Kin L and the BYD Seal 06, both of which entered mass production in early 2024. By the end of the third quarter, BYD had delivered over 500,000 units carrying the fifth-generation DM system. 500,000 cars on public roads. In the hands of ordinary buyers who are not early adopters paying a premium for novelty, they are regular consumers who bought the most affordable, well-equipped hybrid available in their price range, and happen to get the world's most efficient combustion engine in the process. That is what a new benchmark looks like when it actually lands, what the standard now measures. For the last 2 decades, the hybrid efficiency conversation had 2 numbers at its center. The first was fuel consumption in liters per 100 kilometers. The second was CO2 emissions in grams per kilometer. Both of those numbers mattered to regulators, to buyers, and to the engineering teams building the cars. The Xiaoyun engine forces a third number into the conversation: thermal efficiency percentage at the system level, not just the engine level. This distinction matters because previous manufacturers reported thermal efficiency for the engine in isolation, peak efficiency under ideal lab conditions, at the specific RPM range where the engine performs best. BYD reported 46.06% as a system figure, meaning it accounts for how the engine actually operates across a real driving cycle, integrated with the battery, the electric motor, and the regenerative braking system. System-level thermal efficiency is a harder number to achieve and a more honest number to report. It is also harder to game. The implication is that when Toyota announces its next hybrid engine will hit 44%, as its internal targets reportedly now specify, they will need to clarify whether that is a peak engine figure or a system figure. If it is a peak engine figure, the comparison with BYD's system figure is not apples to apples. The industry will need a new standard of measurement, and the company that forced that conversation is BYD. When a company forces the industry to redefine how it measures performance, that company is no longer a challenger. It is the reference point. The window statement here is specific. Toyota's next-generation hybrid architecture targeting 44% is scheduled for production in 2027. Volkswagen's revised EA211 and Evo hybrid roadmap targets 2029. Ford's program is targeting model year 2029 as well. That means the gap between BYD's current production specification and the nearest competitor's announced target is somewhere between 3 and 5 years, depending on which manufacturer you are measuring. 3 to 5 years in the automotive industry is not a small window. It is the difference between a product cycle and a generational shift. A buyer who purchases a vehicle today will own it for 7 to 10 years on average. The buyers who chose competing hybrids in 2024 and 2025 will be driving vehicles built to a standard that was already obsolete at the time of purchase. That is not an abstract concern. It is a resale value problem, a running cost problem, and a consumer trust problem that will compound across every model refresh competitors release before they close the gap. The question nobody in the industry wants to answer. There is a deeper reframe underneath all of this, and it is the one that makes this story matter beyond the automotive sector. From most of industrial history, the countries that built the best engines also built the most prosperous middle classes around those engines. Detroit in the 1950s, Stuttgart in the 1970s, Toyota City in the 1990s. The engine was not just a product, it was an economic organizing principle. It created supply chains, tooling industries, chemical suppliers, software firms, logistics networks, entire regional economies structured around the act of building and selling the world's best combustion hardware. When the benchmark moves, those supply chains eventually follow it. Not immediately, not in a single quarter, but over a decade. The companies that supply the best engine builder with precision components, thermal coatings, fuel injection systems, and engine management software tend to orient toward the benchmark setter. The money follows the specification. BYD is vertically integrated to a degree that no Western or Japanese automaker has attempted. It makes its own batteries, its own chips, its own electric motors, its own drive control software, and now its own benchmark combustion engine. The supply chain that feeds the Xiaoyun engine is overwhelmingly domestic. The economic organizing principle, the industrial gravity, is inside China. This is not an argument about politics or ideology. It is a description of where manufacturing complexity is concentrating. And manufacturing complexity historically is where the high-wage technical jobs go, where the supplier ecosystems grow, where the engineering talent clusters. The countries that spend the next 5 years closing the gap with BYD's thermal efficiency specification will be spending those years chasing. The country that is already past 46% and working toward whatever comes next will be setting the terms for the decade after that. BYD has already filed patents on a 6th-generation DM architecture. The Xiaoyun engine, the one that just rewrote the benchmark, may already be the version they are moving past internally. That is the reframe that matters beyond fuel economy, beyond range numbers, beyond hybrid market share statistics. The question is not whether BYD built a remarkable engine. It clearly did. The question is whether the shift in where the benchmark lives is temporary, a single extraordinary product cycle that competitors will absorb and match, or whether it represents a durable transfer of engineering leadership in one of the most consequential manufacturing sectors on Earth. The honest answer is that nobody knows yet, but the honest answer also requires acknowledging that the people who were most confident it could not happen are the same people who were most wrong about whether it would. Where this goes from here, the hybrid engine is not the end of this story. It is the evidence that a larger shift is already underway. BYD's 6th-generation DM system is already in internal testing. According to filings with China's Ministry of Industry and Information Technology submitted in late 2024, the target thermal efficiency figure has not been publicly disclosed. The fact that BYD is already beyond the Xiaoyun in its development pipeline while competitors are still building programs to match the Xiaoyun tells you something important about the velocity of this gap. The manufacturers who close the distance fastest will be the ones who stop treating BYD as a regional story and start treating it as the primary technical reference. The ones who close it slowest will be the ones still explaining to their boards why the Chinese efficiency numbers should be viewed with skepticism. That skepticism has already cost them time they cannot get back. Before you go, if this video gave you a clearer picture of why a single engine specification can carry implications that stretch well beyond the cars it powers, hit the like button. It genuinely helps this kind of analysis reach people who find it useful, and it tells the algorithm that detailed, sourced breakdowns are worth surfacing. Subscribe if you want to be here when the next chapter of this story lands, because the 6th-generation DM announcement, when it comes, is going to move fast, and the context you have now will matter. And here's the question for the comments, and it is one with two genuinely defensible positions. Should Western and Japanese governments protect their domestic auto industries from BYD through tariffs and trade restrictions, even if it means consumers pay more and get less efficient cars? Or should they let BYD compete freely and force their own manufacturers to match the standard or lose the market? There is no clean answer. Protection preserves industrial employment and strategic manufacturing capacity. Open competition delivers better, cheaper products to consumers faster and punishes companies for falling behind. Both of those things are true at the same time. Drop your position in the comments. And more importantly, drop why. The most interesting arguments in this thread will not be the loudest ones. They will be the ones that honestly grapple with what you are actually willing to trade away to get what you want. See you in the next one.